So here's a video about section 3.8, which is about exponential growth and decay. In my opinion, this section is on the easy side, so I'm not going to say too much about it, but I'll go over some terminology. So there's not too much calculus in this section. There's some calculus. This is, of course, it's about exponential growth and decay, which is right. This is what happens if you have y prime equals k times y. That leads you to y being this function. This is also, at any time you see a problem that has a phrase like this, that y has a growth rate proportional to itself. Which of course is what this equation is saying. This is the growth rate of y, and here is y, and k is like the proportion. So this is saying that the growth rate of y is proportional with y itself. And that leads you to this. But that's it. That's basically the only calculus that's part of this section, is that we are talking about this derivative. But I'm telling you that this is the solution. And now that you know that, there's not too much calculus left in this section. By the way, this number k is called the relative growth rate. That's like what I described as the proportion when we're saying that the growth rate of y is proportional to y. So yeah, let's do an example where we find the relative growth rate. Of course, if I tell you something like, if this were an e, then the relative growth rate would just be 1, because, right, like this is the relative growth rate, as long as you have e in the base. But I don't have e in the base, I have 2 in the base. So what do? One way to do this is to just say that 2 is the same as e to the natural log 2, which maybe this seems weird. Of course it's true. I mean, e to the natural log of whatever is the same as, you know, the e and the natural log cancel, and this is inside parentheses, it is 2. So it's the same thing, but why would I do that? The reason why I'm doing that is because I want to have an e in the base. Of course, when I have a power raised to another power, this is like multiplying the power, so I get the natural log of 2 times t. And now, what did I say? Now that I have an e in the base, k is just this number. Of course, this always works this way, so if you get another question like that, the relative growth rate is just the natural log of whatever this number is. Like if you have some number to the t, and this is not e, then the relative growth rate is just the natural log of whatever that is. Okay. And then we have, there are some online homework questions where they give you some information about a population and how it grows, and then ask you some questions about it. So let's say we have a population that starts in the beginning at 0 days, we have 3,000 individuals, and we have a growth rate proportional to its size. That's giving us a hint that this is exponential growth. So we start at 3,000 individuals. We have this, which means exponential growth. And then after 10 days, we have 4,000 individuals. So the question is, what is the population after 7 days? So let's say, because I know I'm doing exponential growth, I'm going to assume that it has some form like this. All exponential growth, I could have written it this way, but this is like it's just a number times an exponential part. So I'm letting this be my a, and this is like b to the t. So it's easier for me to write this way. This is a description of any kind of exponential growth. So we're talking about exponential growth, so here we are. What do I know? I know that p of 0 should be 3,000. So let me, first of all, I'm going to plug in 0 to my formula. And that just gives me a, because b to the 0 is just 1. And I'm going to set that equal to 3,000. So this is good. The point of this is that I want to figure out a and b, so I just figured out a. So what is the other piece of information that I have is that p of 10 is 4,000. So p of 10, first of all, if I use the formula, that would be a times b to the 10th, which actually I know a, so that would be 3,000 b to the 10th. And that should equal 4,000 because that's what I was told the population was after 10 days. Okay, now this should help me find b. Of course, b to the 10th, if I divide by 3,000, so I will get 4/3. And then, yeah, b would be 4/3 to the 1/10th power, or I could write it's the 10th root. So yeah, I just realized I should make sure, because I'm going to need to use a computer to do this, because I'm not going to get a nice number. But so the question is, what is p of 7? And now we're ready to go. P of 7 would be a times b to the 7th, which would be 3,000 times this. If I raise this to the 7th, the new power is 7/10, right? And we wanted an answer to the nearest whole number, so just hang on 1 second while I type this in. 3,000 times 4/3 to the 0.7 power. 3,669.2, so I will cut off the 0.2. And maybe I encourage you, when you do things like this, to take a second to think about whether the answer makes any sense. And I would say this answer does make sense just intuitively, because at 0 days I had 3,000, and at 10 days I had 4,000. So if I'm looking at 7 days, it should be somewhere in between 3,000 and 4,000. And it was, which of course that doesn't mean that I'm exactly correct. I still could have made a mistake, but at least my answer makes some sense in just because it's in between 3,000 and 4,000. If I didn't get a number between 3,000 and 4,000, I would know for sure I made a mistake, and then it would be time to go carefully check my work. And then there's a part B, which is what is the population after t days. This is easy, not based on the work that we already did. P of t it's a times b to the t, and all I have to do is plug in. So that's a, and then b to the t. If I raise this to the t power, then the new power is 1/10 times t, right? So that's what I got. Okay, so yeah, I'll if you have more questions about this section, then please do ask. But otherwise, since I consider this kind of an easy section, I'll just leave it at this for now. But if you do run into problems, I encourage you to ask me.